YASH Technologies welcome you to the webinar on demand forecasting demo. In a typical buy, make, sell companies, or for that matter of fact, the companies selling services or even in trading, the most important aspect and in our view, the beginning is demand forecasting. The importance of demand forecasting in a company's planning, production, and operations need not be and cannot be overemphasized. The benefits that a company can get from an accurate demand forecasting vis-a-vis the difficulties all across it would face from an inaccurate forecasting are quite evident to all of us. YASH Technologies welcome you to the webinar on demand forecasting demo. In a typical buy, make, sell companies, or for that matter of fact, the companies selling services or even in trading, the most important aspect and in our view, the beginning is demand forecasting. The importance of demand forecasting in a company's planning, production, and operations need not be and cannot be overemphasized. The benefits that a company can get from an accurate demand forecasting vis-a-vis the difficulties all across it would face from an inaccurate forecasting are quite evident to all of us. The current methodologies of demand forecasting, that is top-down, bottom-up, percentage increase or decrease over previous month or the same month last year, or sometimes even by intuition, are creating haywire to companies' business chains and supply chain. Now we will be walking you through the solution and the demo that we have developed over here. So as the solution starts with, as being described, demand forecasting. The demand forecast is a typical time series problem that we discuss about, which is affected by multiple factors that explains the nature of a particular time series variable. In demand forecasting, usually the current solution, the limitations are basically capturing the information from external sources and accurately predicting it using those external sources in the model that is developed for demand forecast. So what we basically provide here is an approach and a methodology which uses advanced time series modeling and advanced other methods such as deep learning neural network methods for predicting the demand forecast or predicting the demand variable according to the other variables that influence it. We also present a univariate models and bivariate models and also multivariate models in the process. So starting with the initial part, we will be discussing about the data over here. As you can see, we import the data from SAP sources. Once the data is imported, we analyze this particular data according to the requirements that we have. So over here, we have the total monthly sales that we discuss about, and also the factors that we identified through subject matter experts. What are the possible factors that can influence monthly sales over here? So this data has been selected and this has been imported to the model that we have developed over here. So the model starts with monthly sales data, that is the time series data on that. With respect to that particular data point, what are the other variables that can influence it? And we call this data influencing variables as independent variables over here. These independent variables, as you can see, would include sulfate content, market share index, price per unit, advertising cost or marketing cost, number of retail outlets, discount percentage, and other factors that we are discussing over here. However, for the analysis, we have selected these independent variables to be most important, and we have developed the models according to this. To start with, we will be quickly taking through the data, which is to understand the data. What is the dependent variable or the study variable that we are discussing over here? And what are the factors that influence externally as well as internally? So as you can see here, the dependent variable that we talk about is monthly sales. And we are trying to predict monthly sales according to the factors that influence it. The endogenous variables that we have considered over here, that includes factors that include independent variables such as price per unit, discount percentage, the discount that is provided on that, the marketing expenditure or the advertisement cost that we have, number of retail locations, sulfate content, and market size index, or which we have noted here as market share. Exogenous factors that we include are temperature, expected consumer income, health consciousness rate, personal consumption expenditure, population growth, consumer price index, total market size cumulative, total market size monthly. These variables have been identified by studying the problem, the current problem, and this has been extracted by understanding the subject thoroughly with the subject matter experts, and we have decided on these variables. Now, moving to the raw data that we have collected or subsetted, as you can see here, we have collected monthly sales data, not just with respect to the total, however, with respect to each region that we talk about, and also with respect to the sub-level stores that we have. And we can call this as micro-level data that we have, as you can see over here. So analysis is not with respect to only the total monthly sales, however, it is with respect to the micro-level data such as each region and each store-level data. The modeling part starts with pre-processing. That is basically we carry out imputation, removing noise from the data, outlier detection, and so on. So that, as you can see over here, we do imputation is carrying out with imputation, without imputation, and by omitting the values which are not available. So we carry out multiple processes for pre-processing, and then we generate a new data set which is used for analysis over here. Now we'll be moving to the first part of the analysis, which is basically univariate analysis. So as the word says, a univariate, we are actually looking into only one variable, which is the sales data. And we are trying to understand what is the trend of this particular variable and analyzing just only that variable with respect to its past values. And in this case, we are not using any other independent variables to analyze or predict the future values or forecast it. So coming to univariate analysis, the product offers, the first part is an extensive exploratory data analysis, which is basically understanding what is the monthly sales, what is the distribution of it, how much sales is more happening at what column or what level, which is happening. Also, we can analyze by region, each region, what is the exploratory data analysis that can be provided for each of them. So the analysis starts with exploratory data analysis. And once exploratory data analysis understood, we analyze the data from a descriptive or exploratory part. Then we move to the modeling part. The modeling, we have multiple approaches that we have selected for univariate approach. The first one starts with ARIMA, which is autoregressive integrated moving average models. These models are based on vector autoregressive models where univariate data is considered and will be used for predicting the future outputs. So as you can see here, the ARIMA model that we have developed is basically based on identifying the parameters which are used for ARIMA model or autoregressive models by itself. So we have used an auto ARIMA model over here, which identifies the parameters required for building the ARIMA model. However, the unique part of this particular product we offer is basically with respect to the sub-micro level data that we have. In fact, if we select a particular region or a particular store, we will be able to extract the information with respect to only that store and the output with respect to that. So over here, we are selecting only the North Store one, and we are using the ARIMA model to predict it. Also, when we start with the analysis, with the ARIMA, we identify what is the seasonality in it, what is the trend in it for further outcome and further understanding of the data. So as you can see over here, we are analyzing a quarterly seasonality in the data. So what is every 3 months, what is the seasonality that is existing in this particular data is being extracted over here through the seasonal component analysis. And then we analyze what is the trend component in the data, which is over a period of time, how much the data changes with respect to time. So that is being captured in the trend. And in the last, the further component that will be left out, which is a very small part of it, which will be left as error component or random component. So the data has been extracted and further decomposed into these components for analysis. And that's where we start with the ARIMA analysis. So once this analysis is carried out, decomposition is carried out, we develop the model and we get a forecast output like this for the next periods that we are talking about. As the data was till December 2016, over here we are predicting the data from Jan 2017 to October 2017. And also, as you can see here, we are doing a sub-level prediction. That is, according to each store, sub-level store, we are predicting over here, also with respect to a particular region that we can predict. For example, for the North region, as you can see, the data is moving like this. The prediction is according to like this. And if we want a further segmentation in every region that we talk about, our South region, we can go up to store level data to predict it. The output that we have can be represented, through a time trend graph as well as a table output, which we can see over here, the point forecast, with the interval that we talk about, with a 95% confidence. So this is the first and primary approach that we have for univariate analysis. The second advanced method that we are using is neural network analysis, which is based on neural network theories and neural network models. As you can see over here, even this has further segmentation in the data with respect to each region or each store that we talk about. Neural network methods work on the basis of developing a particular output by comparing it with the lag values. And these lag values will be feature generated inside the model and feature engineered inside the model, and it will really produce an output which is far better compared to the conventional models such as autoregressive models or time series models such as ARMA. So in this case, we have developed a model which shows a historical trend and what will be the future trends over here. And the forecast output, to get the specific values over here, we show it in a forecast output tab over here. As you can see here, we are talking about Jan, Feb, March, each, what will be the total sales output for that particular time. This is an interesting approach because neural network analysis is a very recently developed approach in recent years, which has been developed, and this output can be compared with respect to the conventional methods that we talk about. And the final outcome that we developed from all these models will be a comparison across it, and on the basis of the accuracy that we get from each of the model, we finalize which model should be applied for predicting the sales. Now moving to the next part of it, the bivariate analysis. Bivariate analysis is particularly with respect to the variables that we identified as independent variables, and each of the independent variable is compared with a dependent variable, which is sales over here. As we have already discussed, the independent variables includes price, discount, market size index, and other factors, exogenous factors such as macroeconomic variables and other demographic variables that we have discussed about. So over here, as you can see, even here we can do a sub-level analysis. We can further drill down to understand what is the relation between the sales with respect to each of the particular variables that we have considered over here. So over here, as you can see, we are considering external variable as health conscious rate, and we see what is the relation between them. A scatter plot basically provides what is the correlation between the sales and the health conscious rate. So although it is not highly correlated, this variable still explains some amount of variance of the dependent variable. Similarly, we have other variables that we can consider over here, which talks about what is the relation with respect to the sales. So this is the primary and the first part of the bivariate analysis, where an extensive exploratory data analysis is carried out, and analysis is carried out through a thorough exploratory analysis or descriptive analysis that is done. In the bivariate analysis, however, we move to a predictive models. Though it is not a lag-based or a time-based modeling such as ARIMA or neural network models, this is to understand what is the relation between a dependent variable and one independent variable over here. So as you can see here, when you consider one particular, if I take the whole country as a region, and then I take price as a factor, independent variable over here, it shows me an accuracy of mean square error of 0.017. However, this would end up in a huge amount of error rate, which you can see with the equation that we talk about here. And this error is also not shown over here. It's the coefficient that we're showing here. With only one variable, it cannot explain much of the variance of the data. So in the trend output that you can see over here, when we fit on the historical data, the actual values and the fitted sales values are much different in terms of the trend. So, however, a bivariate analysis is very effective in understanding the causality in terms of causality. As you can see here, what is the nature of price affecting the sales? This is developed through a response curve, which as you can see over here. And this is further used for understanding the elasticity estimations that we carry out. So this output for a particular range, we can estimate what will be the demand elasticity for that particular period. And that is the application of using bivariate analysis to understand what is the effect of one particular independent variable on the dependent variable sales over here. This is very effective in making strategy decisions on how much price should be changed for the coming period, how much it shouldn't be changed, how much discount should be provided for a particular month or shouldn't be provided for a particular month. So this kind of decisions are derived from basically such analysis over here. Once bivariate analysis is carried out, we move to multivariate analysis. In multivariate analysis, we carry out extensive regression analysis using ridge, lasso, and smoothing and L1, L2 regularization methods. We use such methods over here. In multivariate analysis, as it's obvious, we use a dependent variable as sales and independent variables as exogenous and endogenous variables as explained. So that is introduction to the multivariate. The predictive part, as you can see here, we have two approaches, which is basically one automatic stepwise regression and second manual linear regression. In the predictive part, if you select a particular country or a region, in this case we are considering a country, if we select automatic, it will automatically identify what variables should be considered to predict most accurately with a minimum mean square error and what variables should be fit over here. That will be automatically considered and selected and it will be carried out. In a manual, however, you can choose the variables that you want to consider. As you can see here, I'm choosing the variables that you want to consider. So like this, we can see and analyze what variable when we bring into the model is actually providing more accuracy. So as you can see, the accuracy increases over a period of time, and this can be understood well by the beta coefficients that is generated from the regression equation. As you can see here, from the regression equation, it explains what is the importance of each variable that we talk about, how much beta coefficient is allocated to that. The evaluation metrics over here is again the accuracy metrics that such as mean square error, mean absolute percentage error, root mean square error, and such metrics are used over here. And also, as you can see here, it shows what is the coefficient which is allocated to each of the variable that we discuss about. From this, we can interpret what is the importance of each variable in explaining the variance of the sales data that we have. Now, moving further, we also provide, the product also provides an understanding on basically how a particular variable in a particular period affects that particular dependent variable that we talk about. So for example, if you take quarter 1, quarter 2, for all the data that we have combined, that we have over here, we see how much variable importance is allocated to each of the variable that we have. This is very important making strategy decisions for a particular quarter compared to one quarter to another quarter, which variable should be given more importance. So that is analyzed from this particular output over here, from the variable importance output. Now moving further, we also have sensitivity scenario analysis where the user can in fact change the values of the independent variables that we have considered, particularly the endogenous internal variables that we talk about. And when you change these variables, how the sales output will change over the period of time. This is very beneficial in understanding how basically the market would respond to the price changes or the advertising cost changes and so on. So this is provided through the sensitivity scenario analysis. And also we provide what will be the predicted values for the coming 10 periods if we change these particular values with respect to the time. And this output is provided over here. Now to the final part, we use if the user intends to provide the best value output for the coming periods, and if you want to identify what is the combination of each of the independent variables will provide me the best maximum sales output. If this is the scenario, then the user can change the range that is provided over here and then see what will be the impact of that on the product. So if you press go further over here, it will provide what should be the optimal value that should be given to sulfate content, price, marketing expenditure or discount percentage that we talk about. And what will be the impact of that in terms of sales that we talk about here. So this is what is being provided over here in the demand maximization. This is very applicable in terms of analyzing what should be the right combination or right mix of the variables or the factors that we talk about to get the most optimal or maximum output in terms of sales. In the end, the final tab that we use is basically a comparison across different methods that we talk about. For example, for a country level, north region, south region, north, south, one, different regions that we talk about, what is the accuracy of different methods that we have used? That can be analyzed from here. So the user can identify which method should be used in each of the scenarios that we talk about. So the first tab, as you can see, the univariate model that we talk about is providing what is the mean absolute error and mean absolute error in the neural network model. In terms of percentage, if you want to see, you can see mean percentage error and mean percentage error in terms of each of the approach. So this is what is provided in univariate analysis over here. Similarly, for the bivariate analysis also, we provide the comparison across different models and different regions that we talk about. So this is also provided over here where the user can select what is the right approach that they should be considered for the coming period. In the multivariate approach also, we provide all kind of different methods that we've used. That is basically stepwise and linear regression. What is the mean square error and mean absolute percentage error and total overall accuracy that we provide over here. So this is all analyzed through this particular tab provides an outcome on all of these methods that we talk about. So in the end, what we basically provide is basically it's a combination of different methods that can analyze and predict the demand for the future periods. And we have used multiple methods, and from these multiple methods, we have chosen ARIMA and neural network analysis depending on the accuracy. However, depending on the problem, the algorithm that would be considered or the machine learning technique that would be considered would change from data to data. And this has to be custom-wise developed for a particular business scenario, business data that we talk about. And that is the advantage that is being provided through a custom-made product like this for a particular data that we talk about. So that's with the demo. To summarize the whole part which we have discussed so far, demand forecast at a macro level and in a micro level, what we provide is basically information on a higher level of the country level data as well as on a micro level up to each store level data, which clearly indicates or provides the application or the possibility of understanding which market is expected to grow and which market is not expected to grow in the coming period, and what this product is likely, how much of product is likely to be sold where and how much in which store in the coming future periods. And this would help in understanding the right procurement strategy, right procurement planning, and the right procurement operations, as well as right production strategy, production planning, and also which would end up in a right financial planning for the company. So this is what we provide through a demand forecasting product as such, which we have shown over here. The near demand accurate demand forecast would project revenues and profit more realistically with it.